morning. Today we'll discuss about RMS and average values of AC signals. In the last lectures, we have seen the background of AC electricity, and we have also seen a few key terms regarding AC electricity. We have seen the period, time period, the frequency, how they are to be calculated, and we have seen that sinusoidal signals can be represented in two ways. One is a rectangular form, the other one is a polar form. And also the true representation, what we call it as a phasor form. And we have also seen how phase difference between signals is calculated. Now, in today's class, we will discuss about the RMS and average values of the sinusoidal waveforms. So I hope that by the end of today's lecture, you will be able to determine average and RMS values of AC waveforms. So I will start with simple waveforms, and in the coming classes I'll discuss about sinusoidal waveforms in detail. So before going for this, let me give a simple introduction, and then I will tell you what actually RMS and average value are, and then two more terms, form factor and crest factor, and later on we will move on to the numerical problems on how to calculate RMS value and numerical values of given signals. To mention in detail, AC signal is one whose magnitude will be varying with respect to time, isn't it? It may be periodic or it may be aperiodic, it will be varying. So let us assume that it is varying periodically. This is sawtooth waveform, right? So what is the time period of the signal? This is the time period of the signal, right? And if you take a sinusoidal signal, right, what is the time period? This is the time period, isn't it? 1 by time period is called as frequency. So now if you carefully observe, the magnitude of these signals, whether it is sawtooth waveform or sinusoidal or a pulse waveform or a rectangular one, if you carefully see, the magnitude is varying with respect to time. It is not constant. In case of DC, the signal magnitude is to be constant, but in case of AC, it is varying with respect to time. So it is difficult to say what is the magnitude of a wave, because it varies with respect to time. So if you want, I can say it, at time t is equal to 0, this is the, t is equal to 1, this is the value. At time t is equal to something else, this is the value. Those values are called as instantaneous values. Instantaneous values, which is nothing but magnitude at a particular instance. Magnitude at a particular instance is called as instantaneous values. And there are other ways of how to represent the magnitude. You can go with the maximum value. See, this is called as a maximum value, right? This is called as a maximum value. And you can have average value. You can take average of all these instances and you can determine the average value. Or you can determine the root mean square value, which you call it as an RMS value. Or you can say the difference between, see, this is the minimum value, right? For this one it is minimum. This is the minimum value. So this is positive peak and this is negative peak. So the difference between these two is called as peak to peak value. Okay. So at any given point of time it is called as instantaneous value. If you consider only the maximum, it is called as peak value. If you consider both the peaks, positive and negative peak, the minimum and maximum, and if you take the difference between these two, it is called as peak to peak value. And if you take the average of all these instances, it is called as average. If you take the root mean square of all these instances, it is called as root mean square value. So there are different forms of representing the magnitude of a AC signal. Instantaneous value you can directly say from seeing the waveform. At this particular time, what is the magnitude? And maximum value also you can say directly on watching the waveform. Peak to peak values are also very easy to say. These three can be directly set by observing the waveform. But there are other two parameters, RMS and average, which are a little bit tricky. We need to calculate the RMS value and average value. They are widely used in electronics and communication and also in electrical engineering circuits. RMS value and average value of the signal. And based upon them, we will define two terms. One is a peak factor and the other one is a form factor at the end of this lecture. So today's class is about determining the RMS and average value of a given time varying signal, periodic signal. Okay. So the definitions may be a little bit tough, but try to practice the definitions. And after that, when we do the problems, it will be a lot easier. So root mean square value is exactly what actually root mean square value is. Let us suppose if you have a signal like this, and it is varying after this instant like this. Okay. Now at each and every instant, you take the value. Let us suppose it is x1, x2, x3, x4, x5 at different instance. You square them and add them. And then you take the combined roots. This value is called as RMS value. Understood? Or else, if you just add them and take average, it is called as average value. If you take the squares and add them and then apply the square root, it is called as root mean square. Root is outside, internally each one is a square. Root mean square value. This is average value. Okay, so root mean square means we have to take the square root of the sum of all the values. How many values you need to take? It depends upon you. You can take 10 samples, you can take 20 samples, you can take 30 samples. Normally your computers cannot understand continuous signals, so discrete signals are taken. And okay, discrete concept is above your level, so we will confine ourselves. I hope you have understood what actually RMS values. You are taking square root of the mean of averages. Mean of squares. Root of mean of squares. That is a concept actually. So now, in technical words, how it is defined? It is defined as the DC current. See, root mean square value, we call it as an effective value of an AC signal. Is the value of DC when flowing through a circuit for a specific time period produces the same amount of heat which is produced by the AC when flowing through the same circuit or resistor for a specific period of time. Okay, which means that let us suppose an AC signal is there. What is the RMS value? How to determine RMS value? It is same as the DC signal into X, which produces the same heat just as this one. So RMS value of the signal is equivalent to the DC value of the signal, which produces the same amount of heat for a specific time period. Okay, so this is the concept, technical definition of your VRMS. Okay, it is a measure of the effective value of the waveform. Okay, so effective value of the AC waveform. Now, the other one is the average value. As already said, it is just the average of different instantaneous values. So average value also we call it as a mean value because it is just only the average. It is expressed by that DC current which transfers across the same charge as just like a DC signal. So is equal to VDC, which gives the same charge as that of this particular signal. So an average of a AC signal is equivalent to the DC value of the signal which produces the same charge as the same as that of your AC signal. Okay, during a specified time period. Understood. So what is the RMS value and average value? The definitions may be a little bit tricky, but I hope you have understood what actually RMS values and average values. Now, we have seen instantaneous values, maximum value. These can be obtained just by observing the waveform. Now, additionally, you can calculate average and RMS. Based upon this, form factor can be calculated. Form factor formula is RMS value by average value. Form factor is RMS value by average value. Okay. It indicates the quality of the shape of the sinusoidal wave. Okay. The other one is a crest factor. Crest factor is peak value by RMS value, or I call it as a maximum value by RMS value. Okay. Try to remember. Form factor is RMS by average. Crest factor is peak value or the maximum value by RMS. Okay. So these are the definitions which you are supposed to remember. Now, how to determine the RMS and average values of a periodic wave? Now, let us suppose if you do have a signal and you are able to write the equation of the signal. How to write the equation of a signal, that I will teach you. Okay. So, assuming that there is a signal V of t and it is having a time period of t, if it is having a time period, then automatically I can write 1 by time period is frequency. Okay, so a periodic signal having some time periods. Now, how to determine the average value of this particular signal and RMS value of this particular signal? Try to remember the two definitions, the two equations. Okay, so once again I am writing, if you do have a signal, you integrate it over the conducting times and take the time integral. This gives you average value. If you want RMS value, you take it, the same equation. Additionally, what you are supposed to do, root mean square. Understood? This is the way how you determine the average value and RMS value of a signal. Okay. Hope you have understood this concept. Now we will move on to some specific problems of how to determine RMS value and average value. Okay. So that I'll continue in the next video.